Hello guys, in this video we'll be discussing about Laplace transform. Okay, so first we'll start with the definition. So Laplace transform of a function, okay, of function f of t is defined by Laplace transform. We can write it as L transform of f of t function t, okay, function of t variable equal to f of s, that means function of s, which can be written as integral of 0 to infinity e power minus st f of t dt. Okay, so this is the definition of Laplace transform. So in order to find the Laplace transform of a function which contains t, it is denoted by what? F of t. In some textbooks, we can write it as f bar s of some textbooks. This is denoted by this. Okay, so this is nothing but a function of s. Find the Laplace transform of t, you will get in terms of s. Okay, we'll try to analyze by doing some problems. Okay, now which is equal to 0 to infinity e power st function of t, that is f of t. With respect to t, you have to integrate. Okay, so we'll now look into some standard formulas of Laplace transform. Some standard formulas we'll discuss. So now we'll take some standard formulas. So we'll consider function of t here, then f of s, then condition on s. Okay, these three things we'll discuss. Now f of s means Laplace transform of this function, that means function of t. Okay, so first we'll take constant value. So if we have to find Laplace transform of a constant, okay, that is nothing but a by s. Okay, where a is this value only. Okay, s is a variable we can consider. Now condition of s should be greater than 0. Now, t power n. Laplace transform of t power n is nothing but n factorial by s raised to n plus 1. Condition of s will be same as this, that is greater than 0. If the function is e power at, if you want to find the Laplace transform of e power at, that is given as 1 by s minus a. Condition here is s should be greater than a. Okay, now cos, okay, cos functions we'll discuss altogether. Okay, so fine. So cos hyperbolic at and cos at, sine hyperbolic at and sine at. Now cos hyperbolic at, Laplace transform of this function will be s by s square minus a square. Okay, s by s square minus a square. Condition of s is s should be greater than modulus of a. Now cos at, s by s square plus a square. Condition of s is nothing but s is greater than 0. S should be greater than what? 0. Sine hyperbolic at, a by s square minus a square. S should be greater than modulus of A. Sin 80, S by S square plus A square, S should be greater than 0. Now try to analyze these four formulas. Okay, it's easy to learn it. Now see, this hyperbolic function. See, cos is there. No, now remember this cos. Cos means it contains S. So in numerator S will come. Now see here, sine. Sine means now S term is there. That means numerator you have to write A term. Okay. Now hyperbolic function, that denominator will be same. That means S square minus A square for cos also, even for sine S square minus A square. Now this two difference. See this two difference, that only this numerator term is changing. Here it is S for cos hyperbolic function, and the sine hyperbolic function it is A. To remember this, you can consider this as cos. In name of cos, S is there, so we can consider numerator as S. Here no S, so it will be A. Now to remember these two formulas, sine cos 80 and sine 80, cos contains S, so numerator will be S. Sine does not contain S, so numerator will be what? A. Okay, this should be A. Now the denominator will be what? Same as this. That means S square plus A square. This also S square plus A square. So this is the way in which you can remember. So there are around 7 standard formulas that you have to learn. So based on this, we'll be solving some problems.